Okay, so now we are going to do a review. See if all of this loads for moles and Avogadro's number. So when we talk about moles and Avogadro's number, it's important to remember it's not really different than anything else that you've talked about before when we talk about a collection of things. So when we talk about eggs, we always package them in groups of 12, which we call a dozen. Everybody knows a dozen's 12. A case of soda is 24. And then a mole is just 6.02 times 10 to the 23rd. So we're going to start with some things based on, non-mole things, and then we'll move over into moles. So based on our data in the table, what's the mass of one egg? So here's our egg information. So what I know from this information is if I have 600 grams of eggs, that means that I have 1 dozen eggs. So 600 grams in 1 dozen eggs. Now, I know that in 1 dozen eggs, there are how many eggs? 1 dozen, there are 12 eggs. So I know most of you could go, oh, I know it was 600 divided by 12. But if you do this, you can see that the dozen cancel, and we're left with 50 grams per egg. And so our units work out. So it's kind of important to monitor that. All right. So then the next one, what's the mass of 1 can of soda pop? So here's my soda. Do the exact same thing. I know I have 7.4 kilograms in 1 case of soda. So then in 1 case of soda, I have 24 cans of soda to give me 0.308 kilograms per can of soda. So we're just making sure that our case cancels and we're left in kilograms per can. That's what we want. So now, based on the table, what's the mass of 1 gram of carbon? Okay, so if we do this, we know we have 12.01 grams of carbon in every mole of carbon. So I'm doing this exactly how I did my other problems, in 1 mole of carbon. And mole, let me write this, mole is abbreviated MOL. Molecule has no abbreviation, so don't get the two mixed up. There's mole and there's molecule. Okay, so I know I have 12.01 grams of carbon per 1 mole of carbon. Now I want to get rid of 1 mole. And so what does a mole tell me? A mole tells me I have 6.02 times 10 to the 23rd, running out of room here, atoms of carbon in 1 mole of carbon. And so if I do the math on that, I get 2 times 10 to the minus 25th grams per atom of carbon. So let's just think about how small that number is. That number is a 2, and we're going to put 24 zeros in front of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I got to write smaller zeros. 21, 22, 23, 24. Dot 0. Okay, that is how small the mass is of 1 gram of carbon. So the reason why the mass is so small is because we have particles that are so small. So we use Avogadro's number to count things that are really small because we have so many of them. All right, so 1 mole of carbon is 12.01 grams. That's what we just said right here. So where have you seen this number before? Well, if you look on your best friend, right? Here's our best friend. And we have carbon right here is 12.01. So this is the atomic mass of carbon. And it's from the periodic table. So what's the mass of 1 mole of oxygen atoms? Well, all you have to do is go to your periodic table and say that is 16.00 grams are in 1 mole of oxygen. That's what this molar mass is all about. What's the mass of 1 mole of sulfur? So just pick the next one. So sulfur is 32.07 grams, right? Okay, so now we're going to talk about a molecule. Water is a molecule. We know it has a molecular formula of H2O. So what does that mean? That tells us that we have 2 hydrogen atoms and we have 1 oxygen atom. And so if I want to know the mass of a mole of water, I have to know the mass of 1 molecule of water or 1 mole of water. And then I can adjust if I have a different volume, right? So here I'm going to say, well, 2 hydrogen atoms. If 1 hydrogen atom is 1.008, then I multiply that times 2 and I get 2.016 grams. That's how many grams of hydrogen I have in 1 mole of hydrogen. Then oxygen, I have 16.00 and I only have 1 of them. So that would be 16.00 grams for a total of 18.016 grams. And you can round that to 18.02, which is what they give, grams. So how do we get that number? We looked at all the individual atoms and we added up the mass of the different atoms that are in the molecule to give us the molecule's molecular weight. Okay, how many items are in a dozen? Doesn't matter if it's a dozen apples, dozen bagels, a dozen M&Ms, you always have 12. How many items are in a case? 24. Case of whatever, 24. If you're going to buy paper, you don't buy it by the single sheet, you buy it by a ream. And a ream is 500 sheets of paper. So then how many items are in a mole of anything? If I have a mole of M&Ms, I'll have 6.02 times 10 to the 23rd M&Ms. That'd be a lot of M&Ms. How many atoms are in a mole of carbon? How many anything is in a mole of that same thing? 6.02 times 10 to the 23rd. Doesn't matter what you're talking about. How many molecules are in 1 mole of water? 6.02 times 10 to the 23rd. How many atoms are in 1 mole of chlorine atoms? 6.02 times 10 to the 23rd. Same thing. So the number 6.02 times 10 to the 23rd tells us the number of items in 1 mole of a substance, and that's Avogadro's number. So what are the units? They're anything. They're anything. It's 6.02 times 10 to the 23rd M&Ms, or 6.02 times 10 to the 23rd atoms of carbon, or molecules of water, right? It could be anything. So now let's do a couple of problems. How many atoms, I know I'm gonna have to use Avogadro's number, are in 3 moles of carbon atoms? So if I start out and I have 3 moles of carbon, okay, I wanna get to atoms of carbon. So I know in 1 mole of carbon, Avogadro's number, 6.02 times 10 to the 23rd carbon atoms, or atoms of carbon, however you want to say that. So when I do that math, I get 1.806 times 10 to the 24th carbon atoms. I'm running out of room. It doesn't matter what substance I have. If I'm starting with 3 moles of that substance, it's just 3 times 6.02 times 10 to the 23rd. So how many atoms are in 3 moles of chlorine? Well, that's the same answer. I would just say 3 moles of chlorine, 1 mole of chlorine. The setup is exactly the same, but this time it's going to be chlorine atoms. And I still get 1.806 times 10 to the 24th chlorine atoms, right? So this number stays the same if we're asked how many atoms. But now, what we're asked in number 11 is what is the mass of 3 moles? So 9 and 10 have the same answer. because they're just dependent upon Avogadro's number. But 11 and 12, think about this. If we have, let me come over here. If we are comparing chlorine and carbon, if I have 3 moles of carbon atoms right here, and I have 3 moles of chlorine, which one's going to be heavier? Well, I know an individual chlorine atom is heavier than an individual carbon atom because chlorine has more protons and it has more neutrons than carbon. So chlorine's going to be heavier. So my answer for 12 should be bigger than my answer for 11. So let's see if that holds true. Okay, so 11. We're in our room here. Okay, so I'm starting out with 3 moles of carbon, and I want to take that to grams of carbon. So I have to use my relationship that I know. In 1 mole of carbon, I have 12.01 grams of carbon. That gives me 36.03 grams of carbon. Let's do the same thing, but with chlorine. Okay, so here's chlorine. I have 3 moles of chlorine. Now this case, in 1 mole of chlorine, I now have 34.45 grams of chlorine. So that gives me 106.35 grams, or if we round that correctly, 106.4 grams of chlorine. So which one weighed more? The chlorine or the carbon? The chlorine weighed more. And that makes sense because each individual chlorine atom weighs more than each individual carbon atom. Okay, 13. What is the mass of 3 moles of water? Okay, so let's do 13 right here. Come on. All right, so in order to do this, we're going to start with 3 moles of water. And what I want to do is I want to go from 1 mole of water to some number of grams of water. How do I get that number of grams? Well, I need to know the molar mass of water, and that's what we did up above in number 5. We found the mass, the molar mass of water to be 18.06. And so that's exactly what we're going to do, is we're going to plug in that same number, 18.06 grams of water. And so when we do that math, we get 54.0 grams of water. So this molar mass here, this is called the molar mass, tells us the mass of 1 mole of whatever the substance is. So it's that many grams per mole. So we can do that with anything. So let's do that with number 14. Number 14 is something different. It's methane. We're still going to start with 3 moles of methane, CH4. But now we got to figure out, in 1 mole of methane, how many grams of methane do we have? And so we actually have to go and do that math. And so I would say, okay, carbon, I have 1 carbon. Carbon is 12.01. So that's 12.01 plus I have 4 hydrogens. My hydrogen, if I come over here, is 1.008. Okay, so if I multiply those together and I add them up, I'm going to get 4 point whatever, and then I add them 16.042 grams. So that's what's going to go right here, 16.042 grams. And I do the math and I get 48.13 grams of methane. So you could do this with any substance. All you have to do is find each individual atom, the mass of that atom, multiply however many atoms you have, and then add up all the masses of all the different elements. So your job is to do number 15, to develop for yourself a working definition for the unit of mole, right? But it's just like the way we use a dozen to count eggs or baked goods, the way a ream is used to count paper. A mole is a way to count very small things, very, very, very small things. So it's a way to count very small things, and that's it. That's it. Okay, so now that I've gotten into the next problem, okay, so calculate the number of nitrogen atoms in 0.550 moles of nitrogen. So my goal is to get number of atoms. That's my goal. I'm starting out with 0.550 moles of nitrogen, and you should always put your element, that's nitrogen, okay? So I know in 1 mole of nitrogen, I don't have to go to the periodic table. I just know that I have 6.02 times 10 to the 23rd atoms of nitrogen. Now, do you have to memorize that number? No, because here in your best friend, you have that relationship, right? Okay, it's equal to, and I'm going to put the arrow up here, it is equal to 3.31 times 10 to the 23rd atoms of nitrogen. Okay, the number of moles in 12.5 grams of cobalt. Okay, so I'm going to start with 12.5 grams. And I want my grams to cancel, so I'm putting grams at the bottom. And 1 mole of cobalt. Okay, so now I go to my periodic table and I find CO, and we get 58.93 grams. And that gives me 0.212 moles. Okay, so just make sure your units are canceling. Your moles cancel, your grams cancel, whatever it is. Now, the number of calcium carbonates so the number of, right, so this is Avogadro's number again, 32 grams of calcium carbonate. Okay, so I have to get rid of grams of calcium carbonate. I have to introduce moles of calcium carbonate because I can't go straight from grams to number of particles or atoms or anything like that. I have to go to the moles in between. So how do I do that? I do the molar mass of CaCO3. Okay, so if I do that, calcium is 40.08, then carbon is 12.01, and then oxygen is 3 times, because I have 3 atoms, 16.00. So if I add all of those up, I should get 100.09 grams. And don't round this stuff, just wait to round until the very end. 0.09. Okay, now my grams cancel. Now I gotta get rid of moles. In 1 mole of calcium carbonate, what do I have? I have 6.02 times 10 to the 23rd. And in this case, they're asking for number of calcium carbonates. Because it's an ionic compound and it's really just a ratio, we don't call it a molecule anymore. So we really call it formula units. So this should give you 1.925 times 10 to the 23rd formula units of calcium carbonate. But that's fine. You don't have to know that. All right, let's see. The number of phosphorus atoms in 1.32 moles of phosphorus. Okay, let's see. Maybe I should come down here. So this is number 2. So A, 1.32 moles of phosphorus. And I know I got to get rid of moles. So in 1 mole, I have 6.02 times 10 to the 23rd. And in this case, it's going to be atoms of phosphorus. And that gives me 7.95 times 10 to the 23rd. Gives me 7.95 times 10 to the yeah, 23rd atoms of phosphorus. If we do B, the number of moles in 25 grams of silver. Okay, I know my grams have to cancel. So this one, all I have to do is go to my periodic table and find Ag, right? Because it's only one thing. That's 107.9 grams in 1 mole of silver. And we get 0.3232 moles. Okay, so this is not so bad. It's just kind of like doing the same thing over and over again. All right, C is a little bit different. The number of sodium chlorides in 550 grams of table salt, NaCl. So I'm going to start with this. I want to get rid of the grams on the bottom. And I want to go to moles. So now my question is how many? So if sodium is 22.99 and chlorine is 35.45, you should get 58.44. And that goes right there. Or 4 grams of NaCl in 1 mole of NaCl. Now the problem asks me for number of, so I know I got to go to Avogadro's number. So keep going. 6.02 times 10 to the 23rd formula units of NaCl. I'm running out of room. In 1 mole of NaCl. So what do I get? I get 5.151 times 10 to the 23rd formula units of NaCl. Okay. Now this last one's a little bit different. I'm just gonna put myself another page in here. Okay, then the last one's a little bit different. Let me make this smaller. Okay, so we have a 14 karat gold ring that has a total mass of 65 grams. So I kind of like to just circle it. So this is my total mass. And then I'm kind of given a ratio. I'm told 14 parts of that total is gold and 10 parts are other metals. And this is kind of a cool, it's kind of a cool thing. So we knew the total mass was 65.0 grams, right? And we were told 14 parts are gold plus 10 parts are other metals. And together, all of that equals to 24 parts in total. So this is where the 24 karat gold comes in. 24 karat gold is only 14 parts gold. The other 10 parts are essential because it would be too malleable otherwise and you wouldn't be able to wear it. So, so we call that 24 part gold, we call that 100% because that's what we say. That's like the total. So if I want to know how much is gold, I would say 14. Let's see, 14 is equal to some percent of 24. So if I solve for x, just divide by 24 and then multiply by 100, right? Then what you're going to get is 58% of your total is going to be gold. But we weren't asked what percent, we were asked how many atoms. The goal is number of atoms of gold in the ring. Okay, so what I can then go is say 58% of 65 grams is equal to 38 grams. That's my gold. So if I have 38 grams of gold, can you go from grams to, that's supposed to be a U, to numbers of atoms? Sure, right? I know that gold has 196.97 grams in 1 mole. Just got that from the periodic table. And then I know in 1 mole of AU, and let's make sure grams cancel, moles cancel. I have 6.02 times 10 to the 23rd atoms of gold. So I get 1.16 times 10 to the 23rd atoms of gold. Right? And so now you know where the 24 karat gold comes from. All right, hope that helps.